Now in this part of the video, what we are going to do, we already talked about the initial pH, how we calculate that. Now we want to talk about what happens, how do we calculate the pH before the equivalence point. So the reaction that we're going to look at, we're just going to look at, for one example, 8.0 milliliters, and this is before the equivalence point. So the reaction that we're interested in is HA plus, we are adding base, so our products will be water plus our conjugate base. So what we're going to have, we're going to have a little bit of our acid and then a little bit of our conjugate base. So this is the same as a buffer. This is a buffer, a mixture of a weak acid and its conjugate base. And we are going to make the assumption that all the hydroxide ions are going to react completely with the HA acid that's here. Okay, so we have our buffer, and remember we can use the Henderson-Hasselbalch equation, and pH equals pKa plus log of our base over our acid. Okay, so we already know the pKa. This is already given to us. We have the pKa, which is 4.16. And now we just have to find the ratio of the base to the acid. So there's a couple ways this can be done, and the easiest way to do this is to find approximately how much base there is to acid. So just find that ratio, and the way to do that is to say, okay, well, we have this reaction here, and we know that the relative initial amount is that there's approximately 100% of HA to start with. So this relative initial, so if we set up our ice table, initial amount is going to be 100%, or in this case, 1. So it's going to be 1. And then what you're going to add, in this case we added 8 milliliters. And for this to react completely, we need a 1-to-1 ratio. And to react completely, we would need the volume at the equivalence point. So that would be where we have 1-to-1 ratio of acid to base. So if we take our volume of our base that we added over our volume at our equivalence point, which in this case is 25.0 milliliters, that's how much we added, and we subtract that from the acid. That's how much was subtracted, removed from the acid side and added to the base side. So 8.0 over 25 milliliters. And this is so, and then we're assuming all the base is reacted, so the base, the OH, is going to be completely consumed to form your conjugate base. So what you'll have here is you'll have 1, so that's going to be 1 minus 8.0 over 25.0 milliliters. This will be 8.0 over 25.0 milliliters. Okay, so now what we can do, this is your acid, this is your base. You can plug it into this equation here. This is also going to be the same as 17.0 over 25 milliliters. So let's solve for this. pH equals 4.16 plus log. Let's take our base, which is here, 8.0 milliliters over 25 milliliters, all over 17.0 milliliters over 25.00 milliliters. You notice that the 25s are going to be common, so if you do this out, you'll get get 3.83 pH. And you notice the 25s are also going to cancel out. So basically, if you had the log of 8 milliliters over 17 milliliters, you would have gotten the same answer. So your answer here, you should have pH equals 3.83 for the curve. So what you'll have is that at a volume of 8, you are going to have 3.83. Okay, so that's at 8 milliliters. So now let's find the pH at the equivalence point. So that'll be the next video.